All right, so in this video, we're going to continue where we left off at for lesson 210, where we're looking at graph properties of these different functions. And so one of the things that we need to talk about is limits. Now, we've talked about limits in the terms of end behavior. So every graph has, or not every graph, but every graph will have at most two ends, a left and a right side of the graph. And so there's always going to be at most two end behavior limits. But there could be more limits that are happening inside. So anytime we have a vertical asymptote, we're going to have limits. We're going to have limits at those vertical asymptotes. So I'll show you what I mean by that in just a second. So first, let's look at this example. So we see that we do have a horizontal asymptote right here. And that that horizontal asymptote is at where y equals 0. So that's going to help us identify where the end behavior is going to be. So the end behavior, you would have the left side of the graph, so as it approaches negative infinity for that function, it's approaching 0. And as x approaches positive infinity, so the right side of the graph, it's also approaching 0. All right, so now let's look, though, at those vertical asymptotes. So we have, use a highlighter maybe. So let's look at this first vertical asymptote. So at that vertical asymptote, look at the graph. The graph is doing two things at that vertical asymptote. On the one side here, the graph is going up as it approaches that asymptote. On the other side, the left side, the graph is going down as it approaches that vertical asymptote. So we're going to have two limits happening at each vertical asymptote. And here's how we write it. This is a little bit different. So below here, the value, what's happening here is as x approaches we're not approaching infinity here, we're approaching an asymptote, and that asymptote is at -2. Now there's two sides to that asymptote at -2. There's a left and right side. So to refer to the left side, we're going to use a negative exponent. So that negative exponent refers to the left side. So it's just not really an exponent, we just put a negative up there where the exponent would be. That's referring to the left side of that asymptote. So on the left side of that asymptote, what's the graph doing? The graph is going downward, so it's going down towards negative infinity. So now for the right side of that asymptote, so again, this is for the asymptote where x equals -2. So on the right side of that asymptote, we can see that the graph is going infinitely upwards. So now we would do the same thing for our other vertical asymptote. So our other vertical asymptote, is right here. So for that vertical asymptote, again, we have a left and right side. We can see that on the right side of the graph, let me get a pen. So the right side of the graph is going up, or the right side of that vertical asymptote, the graph is going up. On the left side of that vertical asymptote, the graph is going down. So again, this is for the vertical asymptote at x equals 2. So the way that we would describe this limit is as x approaches 2 from the left, so the left side of that vertical asymptote, it's going downwards. So let me draw my arrow better there. So we have the right side of that vertical asymptote. So the right side of that is going infinitely upwards. Okay, so that's how you would identify the limits for asymptotes, because again, the graph is approaching those asymptotes and it's doing two different things at each asymptote. Now there are when we have more than one vertical asymptote, there's some different possible outcomes we could have for those limits. Let's look at this next image here. So one possible outcome is inside we could have something that's parabolic in nature, not necessarily a parabola, but it'd be parabolic in nature. So you could have something like that on the inside of those two vertical asymptotes. The outside will always be hyperbolic, or I can't speak, we'll just say hyperbolic branches. So that would be the outside pieces. So it could be situations like that, or you could even have something like this. So the outside will always be these hyperbolic branches, and the inside could either be something that's parabolic in shape or S-shaped. So we could have something like that in the middle. So those are the different outcomes that you'd have. And what we would do down at the bottom there, in your guys' notes, you have the same thing. You're going to use the test point method to decide where the branches are, using values for some maybe more helpful than just signs. Okay, so we'll look at an example here now so you can get a better understanding of what that's talking about. So we want to graph this polynomial. Okay, so we're going to use everything that we've talked about so far. So we want to first get that denominator in factored form. So what two numbers multiply together to be -6 that add together to be -1? Be 2 and -3. So there's nothing that cancels out here, so there's no holes in this graph, but there's going to be vertical asymptotes. So there's going to be a vertical asymptote at x equals -2, and there's going to be a vertical asymptote at x equals 3. Now let's look to see if there's a horizontal asymptote. Remember, for a horizontal asymptote, we're going to use the leading term in standard form. So we would have x over x squared. So this would be a situation that's bottom heavy. We end up with 1 over x. So anytime it's bottom heavy, remember that means that you have a horizontal asymptote at y equals 0. And then let's look at any x-intercepts. That would also be useful, and any y-intercepts. So to find the x-intercept, remember that's where we look at anything that can't cancel out. A factor in the numerator that doesn't cancel out would give you your x-intercepts. So we set those factors equal to 0, so we would have an x-intercept at 1. So that'll be the coordinate when x is 1, y is 0. Remember, to find the y-intercept, I just like to look at standard form. The numbers that don't have a variable, because if you put x in there or replace x with 0, we would end up with -1 over -6, which reduces just to be positive 1, 6. We're going to have a y-intercept at 1, 6. All right, so we're going to use this information to be able to sketch a graph. So let's start with our vertical asymptote. So to have a vertical asymptote at x equals -2. Okay, so there's a vertical asymptote. I'd have a vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 0. And we know that there is an x-intercept at 1, 0. And we have a y-intercept at 0, 1, 6. So 0, and then let's say if this is 1, let's put 1, 6 right about there. All right, so now let's sketch this graph. So the first thing we need to do is we need to figure out where is the graph positive, where is the graph negative. So we're going to use a test point method. So we did this earlier in the chapter. So remember, we have our vertical asymptotes at -2 and at +3. So let's test with a number like -3. So if I put -3 in there, we can put that in the factored form. So if I did that, -3 minus 1 in the numerator would end up with a negative number in the numerator. And the denominator, -3, if I put -3 in here for x, remember that means that I'd have -3 plus 2, which would be a negative number. With that first factor, the second factor, -3 minus 3, would also be a negative number, meaning that I'd have a negative times a negative in the denominator, so that'd be positive in the denominator. And a negative divided by a positive would be a negative. So between -infinity to -2, the graph is going to be negative. So let's just sketch what that would look like over here. So the graph is going to be in that negative section to the left of -2. Because we know it's not going to cross over that asymptote. So it's going to be contained in that area. All right, so now we have an x-intercept at 1. So let's also put 1 here. Now you might be able to have an idea of what this graph would look like, but let's test it to see. So to the left of 1, we already know, actually we already know to the left of 1, it's going to be positive, so I'm not going to waste my time. Okay, because it's going to go through that y-intercept, and now it's going to hit that spot. Now remember, it could be parabolic, so maybe it has like a vertex here, and then it's going to come back up again. Or maybe it's going to be S-shaped, and it's going to come down here. And so between 1 and 3, I want to figure out what's going on there. So I already know that here it's going to be positive, again, because we had that y-intercept, so that's why that y-intercept helps us. All right, so between 1 and 3, I need to figure out what's going on. So I'm going to pick 2. So if I put 2 in there for x in the numerator, 2 minus 1, well, that's positive. And the denominator, 2 plus 2, that's positive. And 2 minus 3, that's negative. And so negative times a positive in the denominator would be negative. So a positive divided by a negative would be negative. So I know that the graph would come down like that. All right, so let's do another test point to the right of 3. And if I put 3 in for x, everything ends up being positive. My numerator is positive. My denominator, everything there is going to be positive. Oops, to the right of 3, sorry, should pick 4. So we pick a value to the right of 3. So I pick 4 here. So 4 minus 1 is positive. 4 plus 2 is positive. 4 minus 3 is positive. So everything ends up being positive. So my graph, everything over here would be positive, so it'll look something like that. So that's how we can sketch a graph by just using everything that we've talked about so far. All right, so I want you guys to put this all together. So you guys have x cubed over x squared minus 9. So I want you to factor that down. Notice that denominator is a difference of squares. So make sure you remember how to factor that. I want you to find the x-intercepts, find the y, find any y-intercept, if there is a y-intercept, find any holes, find any vertical asymptotes, find all these different pieces, and sketch a graph. Remember, when you go to sketch the graph, you're also going to need to use a test point method to be able to find those different branches. So why don't you guys go ahead and pause the video, maybe before even graphing it. Why don't you guys go ahead and hit play after you find these pieces, but then maybe just wait to graph it. So I want you to find these pieces first, and then hit play when you're ready to check to see if you found those correctly. All right, let's see how you did. So that denominator would factor down to be x plus 3, x minus 3. I don't have that on here, but let me just write that down. All right, so the x-intercepts, we would have an x-intercept at 0, 0 is how we could look at that. The y-intercept, that would also be 0, 0. And find any holes. There are no holes in this graph. And the vertical asymptotes, we would have at x equals 3 and x equals negative 3. And this one has an oblique asymptote at y equals x. How do we know that? Well, let me show you how to do that. So remember, the x cubed divided by x squared, it's top heavy, so we're going to divide. Leave myself a whole lot of space here. So maybe I'll just go back to the previous slide. I don't know if we'll need the 0x in here. Sometimes you do, sometimes you don't. All right, so remember, if it's top heavy, we have to divide. So we're going to, our original polynomial is just x cubed. So what would multiply x squared by to get x cubed? It would be x. And so then we'd have, this would be just 0x, this would be negative, 0x squared, and that would be negative 9x. There is no x squared here, so then this would be 0. 0x squared, 0x, and then negative 9 times 0 would just be 0. Anything after that 0 would be a remainder. So we don't care about the remainder, so that tells me that the asymptote, the slant asymptote would be y equals x. So if you're wondering how to get that oblique asymptote, that's how you do that. And then for the domain, so it'd be, remember, x can't be 3 or negative 3, so if it helps, use the number line. That's what I did at the very bottom of the screen. And so you could see what the interval would be for the domain. All right, so now let's talk about how we would graph that. So I'm going to place on this graph everything that we know so far. So I know that there's an x-intercept and a y-intercept here at 0, 0. are no holes in the graph. By the way, if there is a hole in the graph, you would just literally use a point on the graph and just put a circle there. Vertical asymptotes is a vertical asymptote at 3, at negative. And then you have a horizontal, you have an oblique asymptote at y equals x. Y equals x would be this line here. All right, so I know that looks strange. Let's look to see what the graph now would look like. And so we're going to use test points. So we'll use test point at negative, oops, that doesn't show up. Use a test point at negative 3. I'm going to use my x-intercept at 0 and my other vertical asymptote at 3. So again, we're just going to pick some points. Let's pick a point like negative 4. If I put negative 4 into the factored form, the numerator, negative 4 cubed, well, that's going to be negative. And the denominator, negative 4 plus 3, that's negative. And negative 4 minus 3 would also be negative. So my denominator would be a negative times a negative is a positive. And a negative divided by a positive would be negative. Okay, so from negative infinity to negative 3, the graph is negative. Now, let's look at our graph here. We have this section, and we have this section. Now remember, our graph is going to be negative in its entirety. So now in that area that I shaded orange, part of that area, the y values would be positive and part of them would be negative. And so that means that our graph is not going to be in that section. Oops, I want a pen here. So that means our graph is going to be down there in that little section. So I know that looks different from what we've seen before. So let's look at the next interval. So that next interval will be between negative 3 and my x-intercept of 0. So I'm going to pick a value like x equaling, I don't know, let's use negative 1. So if I put negative 1 in there, negative 1 cubed, well, anything cubed would be negative. Or I'm sorry, a negative number cubed would stay negative. And negative 1 plus 3, negative 1 plus 3, that'd be positive. Negative 1 minus 3, that'd be negative. So our denominator would end up being negative, and a negative in the numerator divided by a negative in the denominator would be positive. So between negative 3 and 0, my graph would be positive. Okay, so now we're going to see, well, what happens after 0? So let's pick a point like positive 1. So 1 cubed, now that's positive. 1 plus 3 stays positive. 1 minus 3, that's still negative. So positive divided by negative would be negative. So between 0 and positive 3, the graph would be negative. Whoops. And now let's look at the end, that last piece. So let's pick a number like 4, something that's bigger than 3 this time. So if it's 4, 4 cubed is positive, 4 plus 3 is obviously still positive, and 4 minus 3 is still positive. So everything's positive, so it's going to be positive. Okay, so now where is that going to be? So again, if you recognize, we have a couple different sections again. We have this section up here where everything's positive. And then we have this section here where, yeah, there's some positive, but we'd have other values for y that are negative. So that is not going to be where our solution is going to be at. So our solution is going to be where it's always going to be positive, so that's got to be up here. So we draw a graph where the graph approaches both of those asymptotes, both the vertical and the oblique asymptote. So that is what our graph looks like in the end. All right, so the last part, so again, this is what our graph, so the last part is we're going to look at the end behavior. And so the end behavior, remember, we have the two ends. And so this one looks a little different. Oops, let me change my color. Okay, so again, these are referring to the left and right side of the graph. So it does have an asymptote, but it is not a horizontal asymptote. It's an oblique asymptote. If this were a horizontal asymptote, it always approaches a value. This is not horizontal though. It's at an angle. So we can see that the left side of the graph is going to continue downwards. And we can see that the right side of the graph is going to continue upwards. So the left side of the graph continues towards negative infinity. The right side of the graph approaches positive infinity. All right, so now let's look at our asymptotes. So we have two asymptotes, one at x equals -3 and one at x equals +3. So at x equals -3, we have two things going on here. So we're going to be approaching -3. So remember, we're not approaching negative infinity. So we'd say that x approaches that asymptote at -3. So we have the left side of that. So on the left side of that asymptote, so the asymptote we're looking at is this one right here. The left side, the graph is going downwards. So it's going down towards negative infinity. So we have the right side of that asymptote. So on the right side of the graph, or right side of that asymptote, the graph is going up towards positive infinity. All right, so I want you guys to practice this now for the other asymptotes. So practice all this notation. And so I want you guys to pause this video and hit play when you're ready to check to see if you have the other limit correct for when x approaches 3. All right, let's see how you did. So as x approaches 3 from the left, we see the graph is going downwards. As x approaches 3 from the right, we see the graph is going infinitely upwards. So again, it's looking at this and at this. So what's happening as it approaches, as the graph approaches that vertical asymptote at x equals 3. All right, so that's it for the second half of lesson 210. So good luck now as you finish the rest of your assignment.